x4, y7. That's correct. So if you look at this one, I have multiplication between the terms, right? So everything is multiplied together. So I have to look at the like terms, and because it's multiplication, I add their exponent. So 3 plus 1, right? So that gives me x4. And then y2 plus 5, that gives me 7. So I can only go like terms together, okay? So they have to be the same base. And I add their exponents, all right? So if you look at the x's, they're the same base. Add the exponent, 3 plus 1, that's 4. The y, they're the same base. Add the exponent, that gives me 7. How about e? Y24. X10, Y3. Again, this is multiplication, right? So I have multiplication here. Yes? So with multiplication, what do I do with the exponent? I add. That's right. So that's X10. And the Y, that's a different letter. So that's not going to get affected. Right? So the only time that you're gonna multiply is if you have this. Okay? I'm going to write this in a bit different way. So I'm going to write this as 2x7 y4 over x6 y. Okay? That's the same thing as the division. Okay? Same thing as division, right? I just wrote it as a fraction. What do I do with the number 2? Can I simplify it? Can I get rid of it? Can I do anything with it? There's no number at the bottom. It's a 1. 2 over 1 that stays as a 2. I have to leave it. Okay? Now, how about the x? That's right. So 7 and 6, right? They both have the same x, the same base x. And then because I'm dividing, I have to subtract the exponent, right? So that's 7, take away 6. So what's 7 minus 6? That's just x out of 1, yep. And then for the y, same thing. I have y 4 minus 1. Okay? So that simplifies to x to the power of 1. I don't have to write that power of 1. And then y to the power of 3. So my final answer for this is 2xy power of 3. Are you guys okay with this? All right. When I have the power of product, okay, so if you look inside the bracket, I have two things multiplied together. Eyes on the board, please. So I have x to the power of 4 times y to the power of 3. Can I simplify inside the bracket? Can I? I can't, right? Because they're different letters. If they were both x's, then yes, I can. But because there is an x and a y, I can't. So technically, let's pretend I'm hiding that y to the power of 3. Okay? What do you do when you have something that looks like this? Let's say the y to the power of 3 is not there. What do you do when you have something like this? Multiply, right? You multiply the 4 and the 2. Same thing is going to happen when I have two things multiplied together inside the bracket and I have an exponent outside. So what happens is that 2 gets multiplied by the 4 and that 2 gets multiplied by the 3 as well. Okay? So we call this power of product law. So that gives you x to the power of 8 and then y to the power of 6. Okay? This happens when I have multiplication inside the bracket. It's the same thing as the distribution property if you want to think about it. It's the same thing as the one I'm distributing that exponent in. Now, if I have a quotient means division, okay? If I have division also inside my bracket, the same thing happens. That exponent distributes to both terms, the top and the bottom, okay? So let's say if I write this as x to the power of 4 divided by y to the power of 3, all to the power of 2, right? That's the same thing as this. They are exactly the same thing, okay? Same thing happened. The 2 multiplies by both exponents, and that you end up with x to the power of 8 over y to the power of 6. I don't know. I'm more into the writing it as a fraction instead of a division just because it looks cleaner for me. Okay? So this works. That distributive property works for both when I have both multiplication and division inside my bracket. Now, when I have addition or subtraction inside that bracket, that's not going to work. Okay? I cannot distribute that exponent in. Not right. I can't do that. Okay? In this case, I have a subtraction, right? So I can't distribute that 2 in. Do you remember what we did when we had something to the power of 2? Like when we had in the previous unit where we had like x minus 2 squared? Do you remember what we did? But what did we have to do? We had to write it twice, yes? Remember that? Instead of to the power of 2, we had to write it twice. And then what did we do when we wrote it twice? To expand. 4. Remember that? So whenever you have that minus or plus in the middle between the two terms, you're going to have to write it as many times as, like in this case, it's to the power of 2, so I have to write it twice, and I have to FOIL to expand and simplify. So in this case, I have to multiply x to the power of 4 times x to the power of 4. Here, eye on the board for a second. What happens when I'm multiplying x to the power of 4 times x to the power of 4? Do I have the same base? Yes. What am I doing with the terms? Multiplying them, dividing them. What am I doing with the terms right now? Multiplying them. As if I have multiplication with the same base, what do I do with the exponent? Add. So that's x to the power of 8. Then I have to multiply x to the power of 4 times negative y cubed. So that's going to be negative x to the power of 4 y cubed. In this case, can I simplify? No, I don't have the same base, so I cannot simplify. Now I'm going to have to do the same thing with the y cubed times x4. So that's going to be negative x4 y cubed. And then the last thing is negative y cubed times negative y cubed. First, negative times negative gives me positive. And if I have y cubed, I'm going to write it here. Y cubed times y cubed. Same base? Multiplying the two terms. So what do I do with the exponent? I add. So that's going to be y6. Do you guys understand that? Now I'm going to have to look for any like terms. Do I have any like terms in there? Yes. Which ones? That's right. So I have 2 of them, right? I have negative 1 x4 y3 minus 1 x4 y3. So that I can add the exponent, and that becomes negative 2 x4 y3 plus y6. Y to the power of 6. You have to be careful that this is the only case where you have to expand if you have a minus or plus, right? If you have division or multiplication, it's much easier because you just have to multiply the exponent in, yeah? That's an easier one. In this case, when I have a plus and a minus, that's a harder one because I have to do the FOIL. Because I have a -1 and a -1. So -1 minus 1, that's -2. I'm collecting like terms. There's one more thing that I want to explain to you before I can give you some time to do these questions. A lot of times students that when I say you distribute that into everything inside the term, that actually means everything. So here's a term. If I have, let's say, 3x to the power of 3, y to the power of 4, everything to the power of 2. Why 6? Now you have to explain to me why. So you see that square? It's going to multiply with the exponents. But don't forget that there is a term here that has an exponent 1. Yes, it's a number, right? But it's still something. It's a term that has an exponent of 1. So that too also have to multiply by that exponent of 1. So that actually becomes 3 to the power of 2, x to the power of 6, y to the power of 8, which simplifies in terms to 9x6y8. A lot of students either forget totally to distribute that squared in, or they multiply the 3 by the exponent, which is wrong. Okay? So these are the two things that I want to make sure that you guys don't do. Okay? Whenever you have a number in front of your term, a coefficient, you're going to put it right away. Put an exponent 1 on it so you remember to multiply that exponent with the other exponent. Okay? All right, I'm going to leave you guys to do some of the questions and then we'll take them up.